Hello class, I'm teacher Daniel, and today we will discuss the kinds of sets. Sets are classified according to the nature of its membership. Each kind of set has a distinct characteristic or property. First, we have empty set. When we say empty set, it is a set which contains no element. Yes, it is possible to have a set without any element. In symbol, we have braces. And empty set is also known as null set. And the symbol for null set is like this. For example, D is a set of days in a week that starts with the letter A. What is the element of set D? Clearly, we can see that set D has no element because there is no days in a week that starts with the letter A. So the cardinality of set D is 0. So set D is an example of empty set. Next is unit set. When we say unit set, it is a set with only one element. For example, D is a set of the days in a week that starts with the letter M. What is the element of set D? D contains Monday. The cardinality of set D is 1. So therefore, set D is an example of unit set. By the way, another term for unit set is singleton set. Next is the finite set. If the elements of a set can be counted and the counting eventually comes to an end, then the set is a finite. In other words, when we say finite set, it is a set which contains a countable number of elements. For example, V is a set of all x such that x is a vowel of the English alphabet. How many elements do we have for set V? So we have 5 elements. The cardinality of set V is 5. Number 2, P is a set of all x such that x is a prime number less than 10. How many elements do we have for set P? We have 4. So the cardinality of set P is 4. So therefore, numbers 1 and 2 are example of finite set. The counterpart of finite set is infinite set. So when we say infinite set, it is a set which contains infinite number of elements. For example, number 1, C is a set of even counting numbers. So set C contains 2, 4, 6, 8, 10, and so on and so forth. So the ellipsis after the element 10 in set E indicates that the sequence of numbers continues indefinitely to include all positive even counting numbers. We can write this one in set builder notation. C is a set of all x such that x is an even counting number. Since we cannot enumerate all the elements under set C, we will write it in set builder notation. Next is the universal set. It is the set that contains all the elements under consideration. It is denoted by capital letter U. So that is the symbol for universal set. Capital letter U. For example, V is a set of vowels of the English alphabet. C is a set of consonants of the English alphabet. Now, what is our universal set? Our universal set is X such that X is English alphabet. It contains all the elements under consideration. So that's universal set. It contains vowels and consonants. Next is the subset. A subset is a set whose elements are members of another set. So this is the symbol for subset. For example, M contains 1, 2, 3, 4, 5. N contains 1, 3, 5. As you can see, the elements of set N can be found in set M. So therefore, N is a subset of M. In symbol, we can write like this. So again, it is read as N is a subset of M. To see if you really understand this lesson, let us test yourself. Give one example of the following sets. Number 1, empty set. Number 2, unit set. Number 3, finite set. Number 4, infinite set. Thank you for listening. Our next topic is all about operations on sets. Keep updated.